Aerial view of beaver ponds and wetlands thriving amid a charred forest after the 2021 Bootleg Fire. In the scorched Klamath Basin of Oregon, forest biologists encountered an astonishing sight. After the Bootleg Fire ravaged 500,000 acres, streams were clogged with ash and trout had vanished. It just looked like devastation, recalls one fish biologist. But in the middle of the blackened landscape lay a vibrant green oasis. About 5 acres of lush vegetation persisted around 8 active beaver dams. The water there was crystal clear, and trout were thriving as if the fire had never happened. In effect, the beavers had built a natural water treatment plant. Their dam slowed the toxic ash runoff and let sediments settle out. In the words of the field team, the beavers staved off fire-related contamination and saved a refuge of life amid the ashes. Similar scenes have been seen elsewhere. In Washington's Metho Valley after the massive 2014 Carlton Complex fire, scientists found that stream banks with beaver ponds sprang back to life. Burned valleys dotted with beaver dams were alive with young willow and cottonwood shoots, whereas areas without dams stayed parched and brown. Where beavers lived, a parched landscape gave way to willow and cottonwoods, observed one researcher, noting that water is life on a burned range. These real-world wildfires show that wherever beavers are present, pockets of green refuse to burn appear amid the flames. So, can we really team up with beavers to protect our forests from wildfire? And if we do, what might happen next? Beavers' contributions to ecosystems go far beyond just preventing wildfires. Beavers are often called ecosystem engineers, and with good reason. They fell trees with their powerful teeth and pile branches, mud and stones across streams, building dams. This turns a narrow stream into a chain of deep ponds and wetlands. The impounded water spills over the banks, flooding the surrounding valley. By forcing the water to overtop and spread out, the dams slow the current and cause sediment to drop out. This elevates the streambed and raises the water table, recharging groundwater. In creating these ponds, beavers dramatically expand riparian habitat. One review notes that beavers dam streams, forming a series of ponds and wetlands, supporting a disproportionate number of plants and wildlife, including 43% of North America's threatened and endangered species. In other words, hundreds of plant and animal species, from amphibians and fish to waterfowl, depend on beaver-made wetlands. Beaver ponds also trap sediments and nutrients, acting like nature's water filters. By slowly filtering water, they reduce erosion and clean runoff. Indeed, research in the Pacific Northwest found that water flowing through a beaver-dammed channel lost 2/3 of its sediment load by the time it passed the dam. In other words, as muddy, fast-moving water enters a beaver pond, it slows down dramatically. This sudden drop in speed allows heavier particles, like sand, silt, and organic debris, to settle to the bottom rather than continuing downstream. Over time, this process keeps rivers clearer, prevents harmful sediment from smothering fish-spawning beds, and helps stabilize the stream banks. Essentially, beaver dams act as natural sediment traps, cleaning the water and reducing erosion far beyond the ponds themselves. For instance, after Oregon's Bootleg Fire, researchers observed that streams flowing below beaver dams remained crystal clear, while ash and sediment were trapped upstream, almost like a natural coffee filter. This filtering effect helps protect aquatic life in the aftermath of a fire. So while beaver dams don't extinguish flames directly, by holding water and keeping surrounding slopes damp, they create natural fire breaks across the landscape. Because of their profound influence on water, wetlands, and wildlife, beavers are considered a keystone species. Historically, they were everywhere. Tens or even hundreds of millions once roamed North America. But by the late 1800s, they were nearly wiped out by trapping. The legacy is that today only about 15 million remain on the continent. Restoring beavers means re-engineering streams back toward a natural, wet mosaic. The key insight from the wildfire stories is simple: water doesn't burn. The ponds that form behind beaver dams keep the surrounding vegetation moist, creating fire-resistant wet islands within the forest. Think about it like starting a campfire. You'd never choose a wet branch to burn, right? Researchers in California draw the same comparison to beaver-engineered riverbanks. You'd never grab a wet stick to start a campfire. In the same way, banks reinforced by beaver dams don't ignite easily. They're like a pile of wet wood. Indeed, satellite analyses reveal that areas around beaver dams often stay green even during intense wildfires. For example, in several major fires across the western United States, about 89% of beaver-dammed zones became refugia, unburned patches that wildlife could escape to. In contrast, along streams without beaver dams, this figure dropped to just around 60%. In a sense, beaver wetlands act as natural sanctuaries, offering shelter for animals fleeing the flames. In fact, in one multi-state study, vegetation in beaver-dammed reaches remained more than 3 times as lush during the fire compared to other sites, so thoroughly watered that plants simply didn't ignite. These wet refuges do more than survive. They actively slow fire spread. Patches of green marsh and willow thickets interrupt fuel continuity. Fires encountering a saturated beaver floodplain must jump over these pockets. There are many field examples. After Idaho's 2018 Sharps fire, one researcher stumbled upon a lush pocket of green glistening within the burn zone, a beaver wetland that had withstood the flames. In essence, beavers bring water to dry landscapes and create fireproof corridors. It's no accident that in the burned Methow Valley of 2014, stream banks under beaver influence rebounded quickly, sprouting willows and aspens that stabilize the soil. As Alexa Whipple, the director of the Methow Beaver Project, put it, "If we have a wetter landscape, we are going to resist fire and recover from it better." Beavers' value extends well beyond fire. Their dams act like giant sponges on the land. By retaining floodwaters, beaver ponds boost water storage and flows in summer. A British Columbia watershed study notes, beaver dam building enhances water retention, boosts summer stream flows, and bolsters resilience to drought, flood, and fire. Indeed, by spreading water onto floodplains, beavers recharge groundwater and lengthen stream discharge into dry months. This is an economical, nature-based alternative to building dams or levees, helping farmland and forests survive dry spells. The wetlands also dramatically increase biodiversity. Every pond invites a host of species: cattails, water lilies, willow thickets, bog turtles, trout, frogs, dragonflies, and more. In fact, wetland ecosystems, which beavers create, harbor a huge share of diversity. Conservationists note that though wet areas may cover only a few % of land, they support around 80% of the region's biodiversity. By building ponds and canals, beavers literally create new habitat niches. One review found their wetlands support a disproportionate number of plants and wildlife, including many endangered species. And beavers even help with climate change. Their wetlands hold organic material in flooded soils, storing carbon that might otherwise enter the atmosphere. Studies estimate that beaver ponds globally could sequester on the order of hundreds of thousands of tons of CO2 per year. Though quantifying the exact climate benefit is complex, one recent review suggested beaver wetlands may be worth tens of millions of dollars per year in greenhouse gas sequestration. And researchers have estimated that beaver ponds across the planet store up to 470,000 tons of carbon a year. For this reason, agencies like California's Department of Fish and Wildlife now highlight beaver work as a tool to improve climate change, drought, and wildfire resilience. In short, wherever beavers irrigate a landscape, water, wildlife, and carbon storage all flourish. Of course, beavers also come with costs, which must be managed. Their dams flood the land behind them, which can inundate fields, roads, or homes. Studies warn of loss of land because of habitat creation and increased flooding behind dams. In developed areas, this can cause real nuisance. Landowners complain of flooded pastures or submerged yards, prompting traditional solutions like dam removal. Indeed, in both the US and Europe, beavers are often labeled pests for activities like damming roads or cutting trees. As one Oregon report notes, officials view beavers as nuisance when their activity floods roads and neighborhoods, blocks culverts, or fells trees. Other trade-offs include impacts on fish and water. In some cases, beaver dams can impede the movement of certain fish species upstream. Water in beaver ponds is often warmer on average, though with cooler extremes, which could affect temperature-sensitive species. There is also the methane issue. Flooded wetlands generate methane and CO2 as plants decay. One evidence review cautions that beaver ponds are simultaneously paired with increased carbon storage and increased methane and carbon dioxide emissions. Another downside is tree loss. When gathering building materials, beavers often fell riverside trees. And in the forested areas upstream from their dams, standing trees can drown and die as water levels rise. For commercially valuable timber, this can mean an economic loss. While flooding behind the dam may eventually encourage the growth of algae and new plant life, in the short term, it changes the look of the forest and can destroy habitat for certain species. If a poorly built dam collapses, it can also unleash a sudden surge of water, leading to downstream flooding. Additionally, the burrows beavers dig into riverbanks can weaken embankments, or even the dam itself, speeding up soil erosion. In practice, human-beaver conflicts are typically addressed with engineering fixes. Flow devices, screens and culverts let water pass through dams at a controlled rate. The emerging consensus is that living with beavers requires tolerance, plus some safeguards. In short, coexisting with these rodents means accepting some trade-offs. A few flooded fields or gnawed trees, in exchange for all the ecosystem gains. So, what if we decided to actively welcome more beavers and encourage the spread of their dams to protect our forests? On the positive side, it would mean more natural wetland corridors threading through woodlands. Biodiversity would increase, and water reserves would grow during dry seasons, making life in and around the forest more resilient to drought and fire. Ecologically, this would create pockets of green bubbles that help preserve the forest's natural state. But there's a trade-off. Behind every pond lies some loss. A few trees would be sacrificed, and in certain areas, homes or farmland could be exposed to flooding risk. Beavers also tend to build on lowland riverbanks rather than steep terrain, so they can't directly stop the fast-moving wildfires that start high on ridges. And if beaver numbers grow too much, their activity could tip the natural balance of the ecosystem. That's why using beavers as part of forest management, just like any other nature-based method, must be weighed carefully, recognizing both its real advantages and its potential downsides. So, what's being done to strike a balance with beavers? Given the balance of evidence, many land managers now embrace beavers as natural allies. In the United States, agencies and NGOs are actively promoting beaver reintroduction and analogs. California's Wildlife Department, for example, formally recognizes beavers as ecosystem engineers and has launched a beaver restoration program to fund beaver-assisted projects for habitat and wildfire resilience. New funding helps ranchers and tribes build ponds and install flow devices so beavers can stay without causing catastrophic flooding. In 2023, the state even set aside millions in grants for living with beaver solutions, reflecting a shift toward coexistence. Similarly, in Canada, a growing movement called 10,000 Wetlands is using beaver dam analogs, human-built structures, to kickstart wetland restoration and fire resilience in British Columbia. A BC wildlife program notes that by encouraging beavers to build dams, their expertise in dam building is utilized to enhance water retention and landscape resilience. Restoring beavers has the added benefit of low cost. Once a dam is built, nature maintains it. Across the Atlantic, Europe is catching on too. The UK government now licenses wild releases of Eurasian beavers, aiming to create wetlands, increase biodiversity, and reduce flood risk. British conservationists celebrate beavers as nature's aquatic engineers that reduce flood peaks, clean water, and even capture carbon. Legal protection has been granted for beavers in England and Scotland, reflecting the view that their return is a landmark for ecological restoration. Grassroots projects abound as well. In Oregon and Utah, Trout Unlimited and ranchers have begun installing beaver dam analogs, log structures that mimic the geometry of beaver dams, especially in areas damaged by wildfire. The idea is to create immediate wetland benefits, with the hope that beavers will eventually colonize these sites and maintain them. Experts note that beavers aren't a silver bullet. They can't rewater steep mountainsides or fix all fire problems. But within stream corridors, they are extraordinarily effective. As one U.S. Forest Service scientist put it, wet a bigger, broader area, and you're going to keep fires at bay. In fact, one bold ecologist quipped that Smokey Bear's successor might be Smokey the Beaver. In the end, Research shows that beavers are generally beneficial for ecosystems. The water barriers they build can act as nature's own fire breaks, helping forests cope with drought and wildfire. By holding back water, their dams reduce flood risk, boost freshwater reserves, and enrich biodiversity. Of course, these same ponds can also drown some trees in the forest. If we choose to partner with beavers as part of forest management, the goal should be to maximize their ecological benefits while carefully managing the potential downsides. Put simply, beaver dams aren't a silver bullet, but they can be a clever ally, working with us to keep forests healthier and more resilient. Thank you for watching. See you in the next video.